Hello, welcome back, Quantitative Research Methods. We're going to be talking now about reliability and validity. This is Module 5A, specifically on reliability. Reliability and validity essentially help us understand the quality of our measurement, the quality of our design, quality of our analysis. Basically, in selecting a design, selecting a good design involves trade-offs. And those trade-offs are related to quality, and that is reliability and validity. Those are the criteria for a good design, good measurement, and analysis, which is what Voigt talks about in the textbook. With reliability and validity, we can actually determine the quality of our measurement. We can actually determine the quality of our overall study. We can determine how well we can generalize our results to a larger audience beyond the sample that we are looking at, beyond the study subjects that we are looking at. So we're first going to start with looking at the quality and accuracy of our measurements. We had a module on levels of measure. Now we're going to talk about the quality of those measures, starting with reliability. Well, under validity, we're going to talk about three different kinds: content, criterion, and construct. Under reliability, we're going to talk about a number of things too. We're going to talk about consistency and replication, repeatability. What is reliability? We hear people talking about reliability. Essentially, a reliable measure is one that gives consistent results. So it gives the same results again and again and again, no matter on where it's applied and when it's applied, and to the different samples that it is applied to. What it stands for is consistency or repeatability. You can use those words interchangeably, but that's what reliability is. It's also dependent on how clearly you define the variables, which is, if you recall, what operationalization means. Operationalizing our concepts into measures. Reliability is dependent on how clearly they're defined. For instance, these are some examples. How might we determine who is a junior in college? If we went around the room or the internet and asked different individuals how to measure junior in college or how to define that, what are some different ways that one might be able to do that? Well, one person in the course might define it as number of years of education, or further operationalize it, number of years of education. So a junior in college, let's say, has had 2 years. They're going into their 3rd year of college. Another way, though, you could measure this is number of credit hours. And so if you went around the room and asked different people who is a junior in college, you could come up with multiple answers, which would mean that just to say, oh, my measure is you're a junior in college, is not a reliable measure, because you it wouldn't get measured consistently the right way. 2 years versus number of credits. Let's say somebody with at least, I don't know, 30 credits, or no, I take that back. Somebody with 60 credits is a junior in college. What about weight as an example? What could be the issue with the reliability in terms of measuring weight? Well, if you were to get on a scale this in the morning and get on the same scale again tomorrow morning and get on the exact same scale again the third morning, you probably would have fairly reliable results because you're using the same measure, that same scale. But let's say you're going to the doctor's office that day and you measure your weight on your bathroom scale, and then you go to the doctor's office and you measure on the doctor's scale. What is the likelihood that those two weight measurements are going to be exactly the same? In my case, the likelihood is usually pretty low. And so what happens is now we've used two different measures and they're not very reliable because they're not giving, let's say, the same number. Let's look at newspaper readership in terms of reliability. If you ask somebody, how many times have you read the newspaper in the last week? They might be able to tell you that. But if you ask somebody today, how many times have you read the newspaper in the last year? And then you go to that same person a week from now and say, how many times have you read the newspaper in the last year? That's not probably, it most likely won't be a very reliable measure because they would probably come up with different numbers, even in a week's time period. So essentially, reliability can look like this. Here's what we're trying to measure, and this is what all the measurements are with the measuring device that we're using. If they're all right near each other, that's a fairly reliable measurement. If they're far apart from each other, it's not a reliable measure. Reliable, not reliable on this one. There are several ways to assess reliability, and that's the beauty of reliability and validity, is you can actually calculate it, the accuracy. So let's take a look at those different ways. Oh, here's the bullseye. It shows you what reliability could look like. So in the upper left-hand quadrant, we see if you consider the center of the bullseye to be exactly what you're trying to measure, you can see that where these dots are is all over the place, neither valid nor reliable. Well, this is the bullseye, this is what we're trying to measure, and all the measurements are over here, kind of grouped together. They're reliable, but they're not in the bullseye. We're not measuring what we intend to measure. Not valid. With this one, this is basically not reliable or valid. They're all over the place. They're not all near the center. This is what you want to have for a measurement, validity and reliability. All the values are together, grouped in the same place, measuring what we think we're measuring.
This ends this part of the module's presentation. Please move on to review the next part